Module 6, Derivatives of Trigonometric Functions. The objective is to find the derivatives of trigonometric functions. Fortunately, the hard part of the derivatives has passed. Learning how to take the derivatives using the project, quotient, and chain rule was the difficult part, especially ones that required a lot of algebra. For trigonometric functions, the same rules will apply, only the formulas for the derivatives are different. Here are the formulas for the derivatives. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent of x is equal to secant squared of x. The derivative of cosecant x is equal to negative cosecant x cotangent x. The derivative of secant x is equal to secant x tangent x. And the derivative of cotangent x is equal to negative cosecant squared x. Now let's look at a few examples. In example 1, if we're given that f of x is equal to sine of x, then the derivative of f prime of x would be equal to, straight from the formula, derivative of sine x would be cosine x. And we're done with the first example. In example 2, we're finding this derivative. Now here we're going to have to use the chain rule because we have something inside. So f prime of x would be equal to 3/5 times the derivative of the outside, which is the derivative of sine would be cosine. Then we're going to multiply that times the derivative of the inside, which is 15. Now in this case, notice that 15 and 5 will cancel, giving me 3. And so that would be 9 cosine of 15x. Find the derivative if f of x is equal to sine to the 9th power. So we can use the chain rule here. So that would be 9 times sine x to the 8th power times the derivative of the inside, which would be cosine x. Then we can rewrite this as 9 sine 8x times cosine x. In example 4, again, we're going to use the chain rule with tangent cubed of x. So remember that tangent cubed of x is the same as tangent x to the 3rd power. So f prime is going to be equal to 3 times the tangent of x to the 2nd power times the derivative of the inside. And the derivative of tangent will be equal to secant squared x. Okay, and so now let's fix this up. That'll be 3 tangent squared x times secant squared x. And our next two, find the derivative if f of x is equal to a rational function with a trigonometric function in it. So we need to remember that our quotient rule is u prime v minus uv prime all over v squared. So we're going to take the derivative of the numerator, which is going to be secant x tangent x, times the denominator, which is x minus 3, minus the numerator intact, times the derivative of the denominator, which is 1, all over x minus 3 quantity squared. So this will be equal to, let's clean it up a little bit, secant x tangent x times x minus 3 minus secant x, because that times 1 over x minus 3 quantity squared. We now have the derivative of this one. In this one, we need to remember that the derivative of e to the x is e to the x. So f prime of x for this one would be equal to minus 7 e to the negative 3 sine x times the derivative of negative 3 sine x, which is what's inside, which will give us negative 3 cosine x. Okay, and then we're going to put the negative 3 and the negative 7 together and get 21 cosine x e to the negative 3 sine x. Okay, here we In this one we have a trigonometric function with a natural log and a function inside of a function inside of a function. So first we're going to do the outside, so that's going to be equal to negative sine of the inside intact, the natural log of 4x to the 6th, times we've got to do the inside, so that'll be 1 over 4x to the 6th, and then we have to do the 4x to the 6th. We've got to take the derivative of the inside of the natural log, which would be 24x to the 5th. Okay, in our second step, I want us to notice that, get this written down, notice that the x's will cancel and the 4 and the 24 will cancel, which is going to give us 6 over x. And so this will give us negative 6 sine the natural log of 4x to the 6th all over x. And we're done. In example 8, we need to find the derivative of a rational function with trig functions in it. So we need to remember to use our quotient rule. Okay, so we're going to start off. The first one is we need to find the derivative of, and we're going to do the derivative of the first one, which is 10 cosine x, times the bottom one, which is 7 minus 4 sine x, minus the first one, which was 10 sine x, times the derivative of the bottom one, which is going to be times negative 4 cosine x, all over 7 minus 4 sine x quantity squared. And so that will be equal to, and I'm going to go ahead and distribute the 10 cosine x, so that'll give me 70 cosine x minus 40 cosine x sine x plus 40 sine x cosine x all over the denominator. Quantity squared. Notice that these two will cancel, which will leave us with 70 cosine x over 7 minus 4 sine x quantity squared. And I now have the derivative for number 8. And last but not least, example 9, find the derivative of, and we have a chain rule and a quotient rule. So let's go ahead and again, I like to write up my quotient rule. And I'm going to rewrite this function to get it out of the square root. So let's call it sine x over sine 7x quantity to the 1/2 power. So I'm going to first start off, in order to do my derivative, I'm going to do 1/2 of the inside, which is sine x over sine 7x. And then I'm going to subtract 1, so that'd be negative 1/2 times the derivative of the inside. Here comes the fun part, because we've got to use the quotient rule here. So the derivative of the first one is going to be cosine x times sine 7x minus u, which is sine x, times the derivative of the other one, which is cosine 7x times 7, because we have to take the derivative of the inside of that one, all over sine squared 7x. So that's going to give us 1/2, and believe it or not, the negative exponent up here is going to allow these two guys to switch. The top one's going to the bottom one, the bottom one's going to the top one, and they're going to have square roots on them. So it's going to be the square root of sine of 7x over the square root of sine x. So that took care of those. Times, and over here we have cosine x sine 7x minus sine x cosine 7x times 7. So I'm going to put the 7 out here in the front. All over sine squared 7x. And now let's put it all together. So we have the square root of sine 7x times cosine x sine 7x minus 7 sine x cosine 7x. Draw my line a little longer there. And then on the bottom we have 2 times the square root of sine x. And then we have sine squared 7x. And we are finished.